Okay, we want to take a look at ordering real numbers. So it's very important to be able to compare numbers. What's bigger than something else? Are they equivalent and just written differently? All of those matter greatly to us. So we want to be able to do kind of two things. First thing, we want to be able to work with a list of numbers, and we want to write them in ascending and descending order. So ascending order is listing them from least to greatest, right? And I like to think of this in terms of a staircase. When you have a staircase, you would ascend that staircase when you're going up, right? Descending is going the other way. So ascending, going bottom to top, descending is when we go from the top to the bottom, or from greatest to least, all right? So the easiest way to do this, just like with all of the other times we've been working with rational and irrational numbers, is to work with them exclusively in their decimal form, right? And then when necessary, rounding to the nearest hundredths is most of the time sufficient. You can go out to the thousandths if you need to, but decimals are way easier for us. All right, we're also going to be using these symbols here to compare numbers. So this is a less than, and I like to think about this as just an L turned on its side. That's how you can help remember the difference. And then a greater than. Okay. So first up, we just want to take a look at two numbers and use these symbols to compare them. So we can also use the equal to symbol if we need to. So if the numbers turn out to be the same, we can use an equals. So what we're going to do is grab our decimal form. So what is the square root of 15 divided by 2? And we're going to round to the nearest hundredths. So 1.94. And what is 1 and 8 ninths? Okay, grab that as a decimal form, and that's about 1.89. Right? So which one of these is larger? 1.94 is larger. So if you ever forget which symbol to use, just remember the open side always goes towards the bigger one. So I'm going to put the open side towards the bigger number, 1.94, and we are using a greater than symbol. Okay. If you're having a hard time deciding which number is bigger, you can use a number line and place those numbers on there. So if I'm thinking about 0.5, 6, 7, 8, 9, our 0.9 would be there. Our 0.8 would be right there. So a 0.9 will always be bigger than a 0.8. Okay, as long as the leading number, or whole number right here, shouldn't say whole number, I should say the number in the ones place, are the same, right? So whatever number to the left of the decimal is the same. All right, let's take a look at the next one. So pause the video for B and C. Go ahead and try those out. Get them as decimals. See if you can compare those numbers. All right, so welcome back. Let's take a look at how we compared these. So for B, this is where we get into the territory of negative numbers. And we want to remember with negative numbers, the closer to zero, the bigger it is. The further away from zero, the smaller it is, right? The more negative, the smaller we actually consider the number. So it's the reverse of what we think about when we think about positives. So these guys are in between -4 and -5. And we can put our little tick marks to indicate the kind of general decimals. So right in between would be our 0.5. So this would be -4.5. Then we'd have -4.4, -4.3, -4.2, -4.1, right? So if we're thinking about where we would place these guys, here's our negative 4.3, here's our negative 4.4. Closer to 0 is larger, so our negative 4.33 is actually going to be larger than our negative 4.0 because it's closer to 0. So we're going to use our greater than symbol, or open side towards the larger number. All right, next one, we're back to the positives, so very straightforward, back to the positives. 8.3 or 8.4, when we're dealing with positives, I like to just march my way down the number until I hit a number that's different. Then I ask, well, which one's bigger? 8 and 8 are the same. 3 and 4, they're different. What's bigger, 3 or 4? Oh, 4 is bigger. So that means 8.47 has to be my bigger number. Open side of the inequality symbol always goes towards the bigger number, so we would use a less than symbol. 8.33 is less than 8.47. Or we can always read it in reverse. 8.47 is greater than 8.33. So now we want to take a look at this whole ascending, descending thing. So first order of business, we need decimals. Some of these are already decimals, some of these are not. To help organize your work, I suggest, even for those numbers that are already decimals, write it above your list so that everything is a decimal, and that way we can avoid forgetting numbers. So 3.85 is already a decimal. Negative 4.5 is already a decimal, but 11/3 I need to go ahead and put in my calculator and grab a decimal. And I'm going to, again, round to the nearest hundredths, 3.67. All right, and work your way down the line. Figure out what all of these are as decimals. Okay, so we've got everybody in decimals, and I went ahead and did our next example as well while I was at it. And we want to think about what it's asking us to do. So ascending order, that's we're going up the staircase, we're ascending it, we're going from the bottom to the top or from least to greatest. So if we think about our number line, and here's 0, if we're going from our smallest number to the bigger number, we're reading the number line from left to right. So we want to be starting with our negatives and going towards our positives. So the first thing I'm going to do is identify my negative numbers. And some people like to write them below. So you can write negative 4.5, negative 4.67, negative 2, negative 3.5 underneath your original numbers, and only have your positives on the top. And that can help differentiate. So you're not looking at so many numbers all at once. That can be really helpful. All right. So we want to write these all in one big list, right? But we're going to start with these negative values. So we want the smallest. So when we're talking about negatives, we're talking about furthest away from 0. So which one of these is going to be furthest away from 0? And then we're going to walk our way in. So first, that's going to be this guy, negative 4.67. Don't cross it off like crazy because we need to go find it again later. But just give it a little cross off there. Then we're walking in towards 0. What's the next number we're going to hit? Negative 4.5. All right, and slightly closer, negative 3.4, and even closer, negative 2. All right, so we're going from least to greatest. We've got our negatives down. Let's go get our positives. Okay, so this is where things start to get a little bit more normal, right? So if you're thinking about 0, now we're just counting up. So the first number we'd get to would be 1. All right, and now we're all 3 point something. So we want to look at that number after the decimal point to clue us in to what's going to come next. So we would next have 3.67. Okay, and then our next largest would be one of the 3.8s. So we would be going with 3.83. That's our next largest number. And then would come our 3.85. You want to think about placing them from left to right on the number line. And last but not least, 3.92. So this is a set of numbers. You want to keep yourself in set notation whenever possible. And because these are only approximates, right, we did some rounding, we want to rewrite our final answer in the original format that the number came in. So negative 4.67 was originally negative 14 thirds, and we did a little bit of rounding there. Negative 4.5 was always negative 4.5. Negative 3.4 was negative 7 halves. Negative 2 was just negative 2. 1 was just 1. 3.67 was 11 thirds. 3.83 was 3 and 5/6. 3.85 was just 3.85. And 3.92 was originally 5 pi over 4. All right, so it's in set notation. They're in their original form. So we now have our final ascending list of numbers. So let's go do this for our next set, and let's reverse the process and go descending. All right, now I want to look at doing descending. So descending would be reading our number line from biggest to smallest, right? Going from the top of the staircase down to the bottom. So we're reading right to left. We're reversing the process. So the question we're going to be constantly asking ourselves is, what is the biggest number, all right, after we've eliminated one? And I'm going to go ahead and this step right here, I'm going to go ahead and skip it. If you would like, leave it in. It's a good way to check your answer, but it is a skippable step if you're starting to feel more comfortable. And it's okay to skip that. So what I'm going to do is saying, all right, we're doing descending. We're starting with the biggest number, and the biggest number is going to be a positive number. So I'm going to look at my positive numbers. I'm going to say, all right, out of all of those guys, what is the largest? And the answer is 1.5, right? So I want to look at their ones place, compare them. Well, they're all ones. Then I want to go down to the tenths and compare them. So I have a 3, 3, 2, 5, and a 3. 5 is the biggest, that's my largest number. And all I'm going to do is keep asking myself that question. What's my largest number? So I've crossed off 1.5. I have 4 numbers remaining. What is my next largest number? Answer, that should be 1.37, I believe. It's definitely not 1.3, 1.38. There we go. All right, 1.38, fixed that. Okay, so what's my next largest number out of the positive numbers that are left after we crossed off 1.5? And the answer would be that 1.38. So look at the tenths place. We have 3s and 2s. 3s are larger. So now we're going to go look at our hundredths place. We have a 4, 3, and an 8. Well, 8's the biggest one. So we have 1.38, which is really 1 3/8. We had just done some rounding there. All right. 3 numbers remaining. We're going to keep playing this game. What's biggest? Out of the 3 numbers remaining, 1.34 is the largest. And again, what's the largest? 1.33, which was the rounded version of 4 thirds. And we're left with one last one, which is going to come next, which was our 2 pi over 5. Okay, now to get into the realms of negatives. So we're going to be asking ourselves, which is the largest? So negatives are going to work the kind of the opposite of positives. So if we think about these as their absolute value, right? So we make them positive. We're actually asking ourselves, which is the smallest? Because we want to be as close to 0 as possible when we're looking for our largest negative. So it's a little bit of turning your brain around to think about that. So if I'm looking at these, and I can ask myself that question, if they were all positive, which would be the smallest one? 0.4. 0.4 would be smallest. So if I think about it in the negative sense, and I think about, well, what's closest to 0? Well, negative 0.4 would be closer to 0 than negative 1 point anything. So that's my largest negative. All right, so that'd be negative 0.4. All right, cross it off. And we're going to kind of do the same game. So I like to imagine they're all positive, pick the smallest one, and that's actually your biggest negative, right? So you got to get used to looking at that. So if these were all positive numbers, which would be the smallest one? Well, negative 1.29, which is our negative 7/9. Or if we want to think of it in terms of actual negative numbers, we can think which one of these is closest to 0. But that takes a little bit more getting used to rather than just working with them as positive numbers as we're used to. All right, next two. If they were positive, which one would be the smallest? Negative 1.5 would be smaller than 1.67, so negative 1.5 is bigger than negative 1.67. Remember, they work in reverse. All right, and then we have the last one left, negative 1.67, which was the rounded version of negative 5/3. All right, so negatives, you got to play with them a little bit and see what works best for you of how to think about listing them in either ascending or descending order.